So now in this example, I'm going to show you an even faster way of graphing a log function, a basic log function. So they're asking us to sketch the graph of f of x equals log of x, identify the vertical asymptote. So remember, this is the same as saying y equals log base 10 of x, right? Because it's our common log. So if I want to think about this, I can rewrite this in exponential form. I know that this means that 10 to the y equals x. So I'm going to use that relationship here in order to set up some values. I know that x equals 10 to the y, and that I can plug in some y values in order to figure out my x values. So I'll plug in my same favorite 5 numbers, but now I'm plugging in for y. -2, -1, 0, 1, 2. So I know x equals 10 to the y. 10 to the -2 is 1 over 100. 10 to the -1 is 1 over 10. 10 to the 0 is 1. 10 to the first power is 10. And 10 squared is 100. Now obviously I'm not going to be able to fit that 100 on this graph. That is okay. But one thing I want to point out is that whenever you plug in 0 for y, that is going to be our x-intercept, right? And that's going to be a good marker whenever you're doing a quick sketch of your log function. So we also need our vertical asymptote. I know that's going to be x equals 0, and that's because 10 to the y can never equal 0. So I'm going to sketch my vertical asymptote, and I know I'm going to have my x-intercept at 1, and then I'm also going to be here at 10, 1, and then I'm going to be at 1/10, -1, which is an estimation, and 1/100th, -2. That just means we're getting really, really close to that vertical asymptote. And that's x equals 0, and this is f of x. Now, just to get into some good practice, our domain is 0 to infinity, and our range is -infinity to infinity.